What I'm going to talk in the next few seconds is how we are going to bring back aha moments to learning. And the way that I like to translate to Hebrew, bring back the walla moments. Be excited about learning. We started the company slightly over a year ago with a very special group of people coming from different disciplines. We have Professor Raz Cooperman, which is a mathematician, and Professor Shimon Shoken, which is a computer scientist, myself with a deep gaming background, and Shmulik, which has a very deep background in software engineering. And what we realized that we want to solve a global problem called as math phobia. It seems that every household has some person that suffers from that disease, and it's very difficult to cure, specifically if you are infected in a very early age. And math phobia is a problem, because if you hate math, there is no chance in hell that you're going to learn physics or engineering or any of the science subjects later on. What we realize that there is a transformation right now in the world. We are living in a very special moment in time in which big data and tablet and standard curriculum are all merging together and basically creating a new medium. And we are very excited about this new medium. You can see that new medium can provide new opportunities, new ways of learning, and we like to use that opportunity to solve the math phobia problem. So we form a company with the following vision. The first one, we want to improve math education to the masses. We want to do that through tablets. The second one, we want not only to teach the kids how to bypass the PISA or the Meitzav test, but also how to think like mathematicians, build a foundation from early age for mathematical thinking. And three, we want to empower the teachers. We don't want to replace teachers. We think that the teachers are instrumental in that revolution. So without further ado, I'm going to show two of our activities. The first one is a 5th grade subject in Israel or a 6th grade in the US and UK. And in this case, we are going to calculate together the area of a rectangle. What I'm going to do, it's a very simple tiling exercise in which I'm going to tile the rectangle, and by counting the number of tiles, I will be able to calculate the area. So I'm sure that everyone know how to calculate an area of a rectangle. Now let's move to something more challenging, an area of a parallelogram. And that's more difficult. As you can see, tiling is no longer going to be very effective here. So I need to find another solution. What we are doing here, we are not telling the kids what to do. We present a challenge with a set of tools, and we let the kid interact. In this case, I'm using the utility knife, cutting the parallelogram to 2, glue it together, and voila, I have a rectangle, and we just calculate the area of a rectangle before. So what we'll learn here is not only the formula of calculating the area of a parallelogram, but also a very important mathematical principle of reduction. We take one problem that we don't know how to solve and reduce it to another problem that we already learned. Very similar to that, we can teach how to calculate the area of a rectangle, of a triangle. In this case, I'm duplicating the triangles and creating a parallelogram and so forth. Another example, in this case from a kindergarten in the States or a 1st grade in Israel, and in this case it's from an application that was released in Israel named 10 Etzbaot. What do we have here more, bees or flowers? And there are various ways that I can solve that question. I can either count the flowers, or I can count the trees, or I can drag the bees to the flower, and I see that there is one flower without a bee. Therefore, there are more flowers than bees. So pretty much what we teach here is a one-to-one correspondence, which you usually learning a part of a set theory. And set theory is the basic to every functions that you ever learn, but you only learn that in university, in undergraduate school, not on the 1st grade or kindergarten. So by creating a very playful activity, and it's becoming more challenging later on. We run that program in several schools in Israel and on abroad. This is an example from a school in Kafar Kara, which teach in Hebrew and English, and it's embedded into the regular curriculum and class routines. And the program consists of hundreds of learning units. We call them episodes. The idea is that each episode represents a certain mathematical skill, and they are very extremely modular and can match to any curriculum. In a typical class session, if a teacher using it in class, it's between 3 to 4 such activities in a 45 minutes session. We created hundreds of such episodes covering every subject that you can dream from kindergarten to 6th grade. A typical year is 120 episodes. A full curriculum is about 700 episodes. We run it cross-platform completely. And as I mentioned before, the episode can be mixed and matched to different formats. So in this case, if we are matching ksharim and eksharim in Hebrew, we are mapping into that particular curriculum. If we are using everyday math in the States, the same subjects are indexed and can be aligned to that curriculum. And since we are talking about atomic units, they can be either interact as a game by the student, embedded in textbook, whatever the teacher find it suitable. The long-term mission is to open that system to the teacher, to allow them to customize and create their own episode to match the portfolio based on the local culture, best practice that particular teacher has, and so forth. And I would like to conclude by quoting Einstein that says, "I never teach my pupil, I only attempt to provide a condition in which they can learn," and we want to use the tablet and the touch interface to provide that stimulation to the students. Thank you so much.